All right, hey everybody. It's time to get back to a nice little note party. I hope you guys are understanding the volume of prisms and cylinders. We're now moving on to 11-2, which is the volume of pyramids and cones. And of course, a pyramid will always be named based on the shape of its base. Um, and obviously, there will be a square pyramid. That is if the base is a square. There are rectangular pyramids, and if the base is a rectangle, then it is a rectangular pyramid. There are triangular pyramids. Okay. So all of these, we can name a triangle, I mean a pyramid based on the shape of its base, the actual base. Now the formula for finding the volume is very similar to the volume of prisms and cylinders, except it's now just 1/3 capital BH. And again, this capital B represents the area of the base. Remember that will change depending on the shape of the base. And then the height of the pyramid. Height of pyramid. Now the height of the pyramid must be from its vertex, this point right here at the very top of the pyramid, that is the vertex of the pyramid, and it needs to go perpendicular to the base. All right, so that would be the height of the pyramid. All right, so 1/3 capital B H. All right, let's look at one example. Let's look at one example. All right, so check this out. Again, this is 1/3 capital B H. Remember, I will always say capital B. Capital B stands for the area of the base, the area of the base. All right. Okay, so as I look at this pyramid, first thing I'm trying to determine is I'm trying to determine the shape of its base. I'm trying to determine this shape. And it looks to me that that shape is a rectangle. So what that tells me now is my capital B has to equal the area of a rectangle, which is base times height of that rectangle. Okay, so it looks as if the base of the rectangle is 15. The height of the rectangle is 8. So if I do 15 times 8, I end up with 120. Right? The height of the pyramid, the height of the pyramid, that's from the vertex of the pyramid straight down, and it has to be perpendicular. So the height of this pyramid is 10. All right, so volume is 1/3 capital B H. 1/3, I found the capital B, the area of that rectangle, to be 120, and the height of this pyramid to be 10. All right. All right, so here's where, it might be nice to go ahead and go back to that scientific calculator that we've used in the past. If you go to desmos.com/scientific, it pulls up this scientific calculator. And the reason why I do this is because now if I do 1/3, I can actually type it in as a fraction, right? I'm going to move, so I've got, if you look right next to the 1/3, I just hit the arrow button, so it's now next to, so now I can hit times 120 times the 10. And look at that, my answer is 400. So the volume of this pyramid, I don't know why I started to write that, the volume of this pyramid is 400, and it's the units cubed. 400 units cubed. So in this case, this units were centimeters, 400 centimeters cubed. All right. Now remember, if it's a square, then you would use your capital B will be the area of the square, which is a side squared. If your base is the shape of a triangle, then you have to do 1/2 base times height of that triangle. Okay. All right, let's look at a cone. Okay, a cone. Here is a cone. Um, Look at the formula. The formula is the exact same as the pyramid, just like the cylinder was for the prism. The only difference is we can't call a cone a pyramid because there's no the base is a circle. It has no sides, so it can't be like a square or rectangle. It's a circle. So the capital B is the area of a circle, which is pi r squared. And remember that the height of this, just like a pyramid, the height will go from the vertex of the cone straight to the base, and it has to be perpendicular, so it has to have that 90-degree angle, but that ends up being the height of your cone. All right, so let's look at an example. All right, check out this cone. All right, so I know it is a cone. All right, so I know it's a cone, so my volume is still 1/3 capital B times H. All right, so the first thing is, let's look at the capital B, the area of this base, the area of this base. Well, remember, capital B, since the is the area of the base, since the base is the circle, it's pi r squared. Now, if you notice on this example, it doesn't give me the radius, it gives me the entire diameter, okay? Since the entire diameter is 18, then I know my radius has to be 9. All right, so 9 squared is 81. So we have pi times 81, which we normally write as 81 pi. Okay. The height of this cone, the height of the cone is from the vertex to the base, and it has to be perpendicular, which it is. And in this case, it is 8. All right, the formula is 1/3 capital BH. So 1/3, we just found the capital B to be the area of the base. It is 81 pi. And we know that the height of this cone is 8. All right, so I'm going to go back to my calculator. This time I am not going to use the pi because I want to leave pi in my answer. All right, so I'm going to leave pi in my answer. Okay, so 1/3. See how the cursor is flashing next to the 3? Right below this fraction, the a over b fraction bar is an arrow. If I hit that arrow, it moves the cursor to the next, which is good. Times the 81, which we had. Remember what was 81 pi, but I'm not going to put the by button. I'm just going to leave it at 81 times 8. And it gives me 216, but I'm going to keep the pi. So it's 216 pi centimeters cubed. All right. So that concludes finding the volume of pyramids and cones. Um, Hopefully you took great notes. Remember, you can always rewatch these notes. You can find them on YouTube. Remember, you can pause them, copy everything down, replay them, whatever you want to do, but try to get your best understanding of this so that when you start to answer some questions on the worksheet, you have a great idea of what you're supposed to be doing. All right. Hope everybody is doing well, and I will chat with you later.